Hi everybody and welcome. Today we're going to be talking about adding and subtracting rational expressions with common and with uncommon denominators. So that's going to be your goal after watching this video, is to have some comfort going through with the addition and subtraction and working with denominators that are the same, that are different, and of course still simplifying when you get to that last step. So to start off, something that we're going to need to be able to commonly identify and work with today is going to be the LCM, or the least common multiple. So we've done a lot of factoring, but multiple is a little bit different than factoring, so I thought it would be a good vocab word to kind of review here and make sure that we're 100% of the way there on. So this is the smallest possible multiple that two or more, so two plus numbers, have in common. So for example, if we look at a number like 9 and let's say 6, and we want to see their LCM. Well, we can break it down into the factors of 2 and 3 gets us 6, and 9 is 3 and 3. So this is something we've done a whole lot of times, is breaking it down into the factors. But when we're doing the LCM, what we have to do is basically combine these factors by selecting and making sure we're not missing anything that's unique. And it's kind of hard to do, but it's a little bit easier to show you. So for example, we take 9, which has 2 3s, and we write each of those 3s out. And then we look at 6, and we're trying to see, when we get to this number 6, does it have anything to add? Is there anything that's different from the 9? Well, if we take a look, it has 3, so we don't need to duplicate that. We don't need to add it again. It's already accounted for. But it does have this 2, and that's different. So basically start with one of your numbers and see if it has anything unique to add. So 3 times 3 times 2 is going to get us our LCM, or an LCM of 18. So 9 times 2 is 18, and 6 times 3 is 18. That's the least common multiple where they're going to come together. Now I know that the way that we kind of did that might have been a little bit confusing to hear. It's kind of hard to work through. It's a lot easier to do than it is to put into words. But let's try it with another example, and maybe with some of these rational expressions that we're going to be working with today. So x squared minus 3x plus 2 as our first one, and our second one is 2x squared minus 2. Now I'm not going to do the work for these in the boxes. You can do that on the side. Pause the video now if you'd like to do that. But what we're going to do is going to skip ahead to that step. So let's say we've already put these into the boxes, we've already factored them, and we know that our first term here gets us x minus 1 and x minus 2. And then our second term here gets us 2 times x plus 1 times x minus 1. So now it's our job, just like we did before, to write out one of these. So maybe we can start with the top one. So x minus 1, x minus 2. And we're going to look at our second example and see what is unique here. What does it have to add? What more do we not already have written down? Well, we already have written down that x minus 1 there. So we don't need to do that again. So that's taken care of. That's good. We see that accounted for here. What we don't see is we don't see an x plus 1. So we have to add that in. And we also don't see a 2. So we also need to add that in as well. So our full LCM for this would be 2 times x plus 1 times x minus 1 times x minus 2. And I think that's the best way to describe going through it, is write everything down for one of those, write all the factors down for one of them, and then look at the second set of factors and add anything that you don't already see. So this is going to be the way that we're going to find our LCM, our common denominators, when we have denominators that are not the same. So we're going to be able to do a couple examples of that. So first, let's start off with an example where we actually don't need to do this. So if we look at our first question here, the bottoms, those denominators, excuse me, they're exactly the same. So we are actually all set to keep the denominator exactly the same and then just do the subtraction problem. So the subtraction is x squared minus 9. And again, not like terms, so we can't put them together any beyond where that is right there. But what we can do after this is simplify. But to be clear, This is what we're working on today. Can you do the subtraction? After that, though, to get full credit, we do need to fully simplify. So x squared minus 9 is the difference of squares, so you can actually write that as x plus 3, x minus 3. If you don't see that, again, feel free to put it into that 2 by 2 box, and you'll be able to factor it out into x plus 3, x minus 3. We still have x minus 3 on the bottom. So like we were working on actually over the last couple of weeks now, if you see something that's the same on the top and the bottom, you're allowed to simplify those, and you're actually just left with the final answer of only x plus 3. So that's that first full example. Our life is made a little bit easier because our denominators are exactly the same. But what happens when they're not? So we see on our example on the bottom here, we have different denominators. So we have an x squared minus 49, and differently we have 2x plus 14. So we're going to have to do this one step at a time. So x squared minus 49, we can factor that into, again, difference of squares coming up quite a bit here. X plus 7, x minus 7. And then second, we have, and I should do this in consistent colors here, 2x plus 14. Well, we can just factor a 2 out. And again, least common factor is 2. Or GCF is 2, sorry. And that simplifies out there. So just like we were doing to find our LCM now, we can take either of these and write it out. So maybe we'll do the top one again. So x plus 7, x minus 7. And then in blue, what is new? What hasn't been already added here? Well, if we look, we already have x plus 7 added there. What we don't have is a 2. So we need to bring down this 2, and that's going to give us our full LCM. So now that we have this LCM, what do we do with it? So we actually want to rewrite this question now. So we have 2 over x plus 7, x minus 7, and then we have 3x over 2x, sorry, not 2x plus 14, 2 times x plus 7. And we're just taking this, and we're writing them into their factored forms. And what we're going to do now is write in what we need to add to get to our LCM. So here we need to have a 2. So if we do something on the bottom, we also have to list it on the top. So anything that we need to add on the bottom to that denominator to get to our LCM, we also have to multiply by on the top. And on the bottom here, we're missing an x minus 7. So we have to also multiply that x minus 7 on the top. So we're basically trying to fill out that denominator to get to the LCM. Once we do that, we got to make sure we're being consistent. So anything that we multiplied on the bottom, got to also multiply up on the top there. And once we do that, we'll be able to go through and fully simplify a question like this. So I'll kind of box this so it doesn't get in the way of any of our addition that we're doing here. But now that we've done this, we have 4 over 2x plus 7, x minus 7, and then on the other side, we have plus 3x times x minus 7. Now, we always want to check to make sure whether or not we can simplify. So we have 4. Let's see if we can distribute this in. 3x squared minus 21x. And then on the bottom, 2. Whoa. I don't know what just happened there. 2x plus 7, x minus 7. All right, so now that we got this, we can move this over to 3x squared, put these in order, minus 21x plus 4, all over 2x plus 7, and then x minus 7 on the bottom there. All right, I want to make sure, always good to double check at this point, just take a big pause, make sure that no signs were missed, you didn't incorrectly write anything. I know I do it all the time, so that's what I'm going to do right now. I'm just going to double check, make sure that nothing is missing, and we'll be able to go from there. All right, so now we want to take a look at what we have on the top here and just look, see if that is able to be factored, if we can use any sort of combination of a box or anything at all like that to see if this can be simplified any further. And again, this is the next step from what we're doing today. So today, again, we're focusing on getting to the LCM. We're really focusing on getting to this step right here. The rest of this is, again, further simplification, but again, still important to do because when you get to the ACT or SAT, that's what it's going to look like. You're going to have these challenge questions that you're going to have to dive into and get to that full simplified answer. All right, so we know that the only options here are 3x and x. In 4, there are a couple of different options. So maybe we can see how this would work. Maybe we could put a 4 here and a 1 here. And maybe they should both be negative. That way we can get to that negative middle term. Yeah, it doesn't look like there's anything that we can do to that top term to simplify it at all. So that 4 and 1 didn't work. We could try like a, I don't know, maybe like a 2 and a 2. That's still only going to get us 8 for the center term, which is not even close to big enough for that 21x term. And that's really all that we can do there. So it looks like can't be further simplified. So our final answer is actually just going to be right here. Always good to check and eliminate that as a possibility. Make sure you can't factor it out any further. Very commonly you can, but also wanted to show us an example where we can't factor it out any further, where, you know, that's it. And that's okay that that's the last step. Have some confidence, but always, always, always do that extra step. Always, always, always make sure you're going to that final factored form to make sure that you're checking to make sure that nothing is in common on the top and the bottom. But your full final answer for this addition problem gets us down to what's highlighted in blue there. That's what you would submit. So a challenging question for sure. Quite a few terms that we have here, quite a few steps that we're going in and writing out and doing the multiplication, doing the addition, doing the factoring. But if you can put all these together, you'll be in really good shape for, again, I think definitely a challenge kill today, but one that's very accessible if we take the time and show the work. So appreciate, as always, everybody tuning in. If you need any help, email, book an appointment, any of those things. We want to make sure that you can get 100% of the way to where you need to go. I'll see you all in Teams.